In this video, we're going to talk about the basics of elementary matrices. Recall the three matrix row operations: interchanging rows, multiply a row by a scalar, and add and subtract rows and scalar multiples of rows. An elementary matrix differs from the identity matrix by a single row operation. Here are some examples of how elementary matrices can be used to perform row operations. For the first example, we'll use an elementary matrix to interchange two rows of a matrix A. We'll let matrix E, our elementary matrix, be equal to 0, 1, 1, 0, so that we can interchange rows on matrix A, which is equal to 2, 3, 7, 4, 1, 9. The challenge in working with elementary matrices is knowing which elementary matrix will perform a specific row operation. Pay careful attention to these examples so that you can perform similar row operations for different matrices. So here, we want to interchange rows 1 and 2 on matrix A, so we chose the elementary matrix E equals 0, 1, 1, 0. We multiply the matrices together. You can do this by hand or using a graphing utility. And you'll obtain the result 4, 1, 9 in the first row, 2, 3, 7 in the second. So using our elementary matrix, we've interchanged two rows. For our second example, let's show how we can use an elementary matrix to multiply a row of another matrix by a scalar. Suppose we have matrix A, a 2 by 3 matrix, where the first row is 1, 7, 8, and the second row is 4, 2, 1. Now let's suppose we want to multiply each element in the second row by 5. So we're going to multiply each element in the second row by the number 5. An elementary matrix that will do this job is the elementary matrix E equals 1, 0, 0, 5. So multiplying matrix E times matrix A we have 1, 7, 8 in row 1, 20, 10, and 5 in row 2. Let's look at a third example. To 3, 6, 2, 1. and elementary matrix E is equal to 1, 0, 4, 1. So multiplying together matrix E times matrix A, we end up with the following result. A 2 by 2 matrix with first row 3 and 6, second row 14, 25. Actually here, we actually should change our original statement to 4 row 1 plus row 2 equals row 2. I made a typo by mistake there. Instead of a 3, that's a 4. When you work your matrix multiplication, our elementary matrix 1, 0, 4, 1 is equivalent to multiplying the first row of matrix A by 4 and then adding 2 to each entry in row 1, then storing it in row 2. So now we've covered how to use elementary matrices for each of the 3 types of row operations. We can use elementary matrices, therefore, to find solutions to systems of linear equations in matrix form. This concludes our example. I hope you found it helpful, and we'll see you next time.